Hello everybody, my name is Norman Jester. I'm the CEO of Mexico Internet Exchange, and we're here talking about smart cities. The idea behind smart cities is basically to use technology to improve the quality of life. And we can talk about all those concepts and how those affect everybody and how you can implement them and everything, but before deciding to build a smart city, we first need to know why we want to build a smart city. What's it going to benefit? Is it transportation, healthcare, waste management, water management, police, fire, and other emergency services? Are we looking to establish better communications between the people of the country or the people of the city and the local municipalities? My background comes from many years of experience, and I'd like to share with you a little bit about where I come from and why I can stand here today and tell you some certain things that you need to know about the internet and how it relates to smart cities and networking and how it relates to smart cities. And what I'd like to do is sort of just go down a little bit about my background and then explain to you things that I know and hopefully help you along your way to create your city as the smartest city it can possibly be. I was on the internet before it existed, basically. I was running dial-up BBS systems before anybody knew what the internet was. I had modems in the very early days. I watched telecommunications evolve. I watched the very first emails get sent out. I've used the very first computers. I watched as cities started connecting together, actually starting with universities, and then multiple network providers started connecting together, and it kind of grew on its own, and I watched it grow. And what's really interesting about that is when you start at the very beginning of something, especially such a new technology, you get to watch it grow, you see its successes, and then you watch it fail as well. You see all the failures, and you take note of those, and you tell yourself, I will never do that because I've watched so many people try and fail. But then you see what works and the successes. And if I go down, let's just say the overall history of thing, I mean, I could keep you here all day and night, but just to skip forward a little bit, I sort of learned to predict what will and won't work by learning from my own mistakes and from other people's mistakes, as well as from my own successes. Because when you have a success, not only do you have a success, but you have a way to make it better. Like you can take a success and build on that. And then you might have a little glitch along the way and you learn not to do that and things just evolve, right? So what we're here to talk about is not specifically the smart city itself, but what it takes to make the city smart. Now, there's sort of a need to have everything connected to everything. And they call that IoT in today's slang, Internet of Things, right? Which is, I think, it's a silly word, but it's used, so I'll use it. It's the Internet of Things. But how do you have an Internet of Things when you have no infrastructure? And that's what we're here to talk about. We're talking about you want to make your city smart, but how can it be smart? All these ideas that you have, you want healthcare connected, you want fire departments connected, police departments, you want everything connected to everything, but you have no means to actually do it. See, you have the body, which is the ideas, but you don't have the brain to connect it together. And if we look at the world and how it's evolved with networking, and we look at the successes, for example, it is a well-known fact that the internet in the United States is so much better than it is in Mexico. And then you wonder why. Why is it better? I'll tell you why. When the internet was created, it wasn't created as a business. It was created as an experiment of how things can connect to other things. And if you study the history of it, there's some, DARPA related stuff with the defense projects and things like that. But once it got into the hands of the hobbyists and the hackers of the world who were just interested in technology, they turned it into something that was a community. And that community evolved and it spread all across the United States. And the reason that our network works is because everything is connected to everything. Now in a second I'll show you some maps, but what we're going to discuss are internet exchanges and what makes the United States and other successful internet countries, or successful smart countries for that matter, what makes them tick, what makes them work. And that is having open internet, open communications, policies and standards in place for infrastructure. And that's something that Mexico as a whole lacks, and we need to fix that. I'm going to show you some maps right now. Take a look at this map. It's the USA. The dots that you see are all internet exchanges. Now what is an internet exchange? An internet exchange is a building or place. We call them telco hotels, where wires come into the building and they go into patch bays, and each internet company connects to each other. They peer with each other. And they do this through routing mechanisms and other different types of switching fabrics. But what they do is they exchange information with each other. See, what you have to realize is the internet, it's basically a network of networks. And in the United States, looking at the map that I showed you, you have a network of networks. Everybody is connecting to everybody, and that's why everything is so fast. When you send an email to somebody, it doesn't have to go all the way up to San Francisco, then across to Miami, then back to Texas. No, it can take a shorter route. It can go from San Francisco to Arizona to Texas. Why go the long way around when you can take the short way around? That's what internet exchanges make possible. But internet exchanges make something else possible. Interconnectivity, powerful, flexible internet connectivity. Not just internet, but inter-building connectivity, inter-network connectivity, connectivity to the greater internet, connectivity between hospitals, municipalities. Internet exchanges are a center of interconnectivity, and they should be exploited to their fullest potential because that is how a smart city is made. That gives you the means to connect everything that you want to connect to it. If you want to, for example, connect the police department with the fire department, it could all be done through an internet exchange. It could also be done through a direct fiber cable between those different utilities. And that could be done in the internet exchange itself, whether it's going through a public switching fabric or whether it's going through a private one, it's still a direct connection. If we look around and we see the United States, and then we look at Asia and Africa, even Africa is covered with internet exchanges. Hundreds of them. Asia, hundreds of them. Australia, New Zealand has internet exchanges. I mean, they're out in the middle of the ocean. They have internet exchanges. Why does Mexico have none? Take a look at Mexico. Take a look at this map. Oh wait, did somebody forget to put the marks on there? No, they didn't. They don't exist. There's two little dots down there, but they don't even function. I mean, nobody ever really has heard of them. I don't even know what those are, but I'll tell you, I've tried to reach them, couldn't contact them. They don't really exist. So the actual country of Mexico has no real internet exchanges, which is why we're creating the Mexico Internet Exchange. That's the first step. But we're not here to talk about me, we're here to talk about you and how you can make a smart city. We must change to move forward. The network is the brain. Your ideas are the body of the smart city. With the network, all of your ideas can actually be possible. Let's talk about data sets. In a smart city, you're using technology to measure people, places, events, things, water flows, electrical flows. All of this can be created and put into data sets. And if you publish those data sets as open data sets and let any business who needs to access them review them and study those data sets, businesses can study the local environment better and improve their businesses. The government can monitor water flow and figure out better ways to route the water, better ways to conserve water. I mean, we do want to be green, right? I mean, let technology help us. Let it help us by using the smart city approach. We save ourselves a lot of effort. Everything becomes more efficient suddenly. It no longer takes us 10 to 15 years to realize that, wow, we should have been routing this water this way instead of this way, and we probably would have saved 100 million gallons of water or something like that. I could go on all day about what makes the smart city smart, what you can connect. I mean, you can connect light bulbs, you can connect traffic lights, you can connect police cars, trains, subway systems, bus systems, monitor people in and out of areas. You can track automobile accidents. So you can make a smart road, a road that detects automobile accidents automatically and automatically diverts traffic to avoid congestion, while at the same time instantaneously enabling rescue workers to react instantly. There's nothing better than that. And guess what? We're free of the burden to have to think about that too much because our systems, if designed well, will do that work for us. And let's just talk about the untold challenges of designing smart cities. What we must do is connect the unconnected. And in order to do that, to connect the unconnected, we have to build this infrastructure. But in order to build the infrastructure, you can't put the cart before the horse. You can't say, oh, well, we're going to create smart traffic lights when you have no way to connect them. So you have to do it the right way. You have to first get all the local politicians on board, get whatever support you need, and build infrastructure in your streets. Lay fiber under the ground to protect it. Why make it ugly and put it on telephone poles if you can avoid that, right? Put it under the ground. Make fiber rings throughout your city. Create an internet exchange, an open peering point where anybody who is involved in internet connectivity and networking in general can tie their own network into to peer with everybody else who they need to peer with. Now, you do that, and all of a sudden, you have the ability to connect everything else. But it starts with the politics of it all. You see, because if you can't get the infrastructure, if you don't fight for that, then you're left with a lot of ideas and not a lot of shovels to do the work with. So where do we go from here? We get everybody together, like you are right now, and we teach them. Build internet exchanges, lay cable and fiber in your streets. Forget copper, lay fiber. That's all it is these days. Fiber is ultimately expandable. It's light. Nothing purer than that, right? I'm an internet purist, a networking purist. I want to see technology used to improve the life of others. You have to take a lot into consideration when you're running a smart city. Yeah, it can be used to improve the life of others, but let's talk about security for a minute. Now you have this network. Now, you've solved a lot of problems. You've created the smart city, but what else have you done? You've opened Pandora's box, and now you have a lot of other problems. These problems can be dealt with. That is security problems, information leaks, hacking, DDoS attacks, corporate espionage. All of this type of stuff really goes on. I deal with it every day in the United States. As a matter of fact, the reason I can't be there today is because I'm here in the United States working on a government project. So unfortunately, I wasn't able to attend in person. I see this going on constantly all the time. And Mexico might see a little bit of it. But as Mexico evolves, as your smart cities evolve, as you all become interconnected, these problems are going to catch up with you really, really fast. They're going to become more prevalent like they are in the United States and other countries right now. I mean, how much news do you need to see about Russian hackers and Chinese hackers attacking the United States? I don't really hear that about Mexico much. I mean, there might be one or two incidents, but they sure slip by me. You could take all of the network capacity in the world, but whenever you create something new, there's always going to be scandalous people trying to do something bad with it. So what else do you do? In your cities and in the country, you create network operations centers. The network operations centers should monitor and control all of the connectivity within the local government, within the city infrastructure in general. Those network operations centers can respond instantly to DDoS attacks, they can monitor for hack attempts, and they can keep your city secure. Now, if you need to know how to do this, please do feel free to call me or email me. I'd love to help you. Again, I want to see the internet and networking in general and technology used to help people. So let's think about this for a minute. Everything is good in the United States with the internet. Connectivity just works. All of our schools, our children have iPads, Chromebooks. They're not carrying books to school anymore. It's all digital. I want that for Mexico too. I think it's starting to slowly happen. I keep hearing things here and there, but a lot of the times I hear that, most of the schools in Mexico have no internet. And why is that? Because the cities don't have infrastructure. So how are you going to make a smart school in that smart city? You really can't unless you have that infrastructure. Now, let's look at it from a whole other perspective. Security of the city itself. I've heard, for example, that there are street cameras all over Mexico. Most of them don't work because they don't have the connectivity they need. Perhaps they had connectivity at once, but the company who was doing it was not reliable because the infrastructure wasn't there to support that internet company and the bandwidth demands were too great. Many people are saying that Mexico needs help in these areas. Your city is a part of Mexico. I'm talking about Mexico as a whole, but I'm also talking about your city because we're not just trying to create a smart city, we're trying to create a smart country. And it all begins by doing each piece of the puzzle, and that begins with you. So you're in a powerful position, the position of beginning, taking those leaps, moving forward, taking the steps to make these things happen. And if you do that, I promise the outcome will be great.
If you've ever phoned or emailed someone on another continent or browsed a foreign website, you can dial up some gratitude for something that happened a century and a half ago.
It's been 150 years since the first transatlantic cable began ushering in global communications. And now tech giants are taking that undersea revolution a big step further. Here's Mark Albert.
When you pick up the phone to reach out and touch someone across the oceans, it's only possible because of ships like the Global Sentinel.
This is cable tank number 1.
And what am I standing on right now?
We're standing on fiber optic cable that's going to be laid from here towards Brazil.
This is how worldwide communication begins. Jeff Sanders is a captain at TE Connectivity Subcom, which calls itself the world's largest provider of under-ocean fiber optic cable.
They're calling it the same way they did in the 1800s.
He gave us a rare view of more than 900 miles of cable spooled tightly by hand in one of 3 side-by-side tanks aboard the ship anchored in the port of Newington in New Hampshire.
So the cable we're walking on right now will be under the ocean carrying my phone calls?
Yes, it will. It's a good chance any call you make to South America in the future could be on this exact cable for the next 20, 25 years. Cable comes right off into the ocean from here.
Robots take over from there, diving to a depth too deep for humans. The machines use water jets to create a trench, allowing the cable to sink into the seabed and become buried.
95% of all telephone and data is transferred over submarine cables.
Not satellite.
Not satellite.
It's what allows us to rely on instant everything. Phone calls, banking, web surfing, email, streaming video, and other communication. And it all began 150 years ago.
We have here samples of the early cables from the 1850s.
This is what the first permanent cable looked like under the Atlantic.
Absolutely.
Barney Finn at the Smithsonian's National Museum of American History helped string together an exhibit commemorating the 150th anniversary of the first permanent transatlantic cable, and the man who assembled the financial, political, and technical prowess to make it happen, entrepreneur Cyrus Field. Some of the items have not been on display in more than a century.
And this indeed is the cable going across the Atlantic.
Late in rough seas, the first few copper cables broke or burnt out. When it finally worked after a decade of failure, Field wrote to his wife on July 27, 1866, "All well, thank God." Great Britain's Queen Victoria congratulated U.S. President Andrew Johnson in this message.
If I was living in 1866 and I wanted to send a message to a relative in Ireland or in England,
Right.
it would take 10 days by ship to get there, however long to write the message, and 10 days to get back. With this cable now, it was what, minutes?
Yeah, that's right.
It sounds like this was the original information age.
That's right.
For the next 90 years, the cable handled messages by Morse code before telephone cables arrived. Today, a maze of fiber optic cables crisscross the oceans and the U.S.
What is the main challenge in moving vast amounts of data?
Capacity.
Mike Murphy co-founded the Boston-based telecom consultancy NEF. He says the explosion of data use around the world is leading to innovative partnerships like Facebook and Microsoft, which have teamed up to build a blazing fast 160 terabyte per second cable from Virginia to Spain.
What does this mean for the family sitting at home logging onto the internet?
Better, faster service. So today we live in a world of instant gratification. So if you're standing in the grocery store and you want to see what's in your refrigerator to finish your shopping, you can actually access a camera inside your refrigerator. Think about driverless cars. And think about the amount of data that's required.
It sounds like what you're saying is these companies building these new transatlantic cables, they're not going on offense, they're on defense, trying to keep up with all the growing traffic.
For sure.
We can transmit the entire contents of the Library of Congress across the Atlantic Ocean in 2 seconds.
At the TE Subcom plant in New Hampshire, the company uses colored glass strands of fiber to create the cables for those over-the-top providers, like Google, Facebook, and Microsoft, explains Vice President John Dufour.
Look at how thin these fibers are. This is like a hair.
These are the size of a strand of human hair, but about 1,000 times stronger.
And demand is just as strong. The cable highway runs to the Global Sentinel ship 24 hours a day until fully loaded. Once installed in the dark depths of the ocean, it'll be a highway of fiber optic light.
It's connecting the world and connecting families, and it's a mission that we enjoy doing.
For CBS This Morning Saturday, Mark Albert, Newington, New Hampshire.
It's amazing. And Mark sent us these thin little threads.
Yeah, it's
Have
housed
all
in there. So they
information.
put it under. It's housed in a thicker thing, but the actual cable itself, I mean, you can barely see it. And this is what the Library of Congress is traveling in 2 seconds.
That's astounding.
Yeah, it's extraordinary. Wow.
After that little video, I wanted to talk about infrastructure and how to keep your city online. See, if you build a smart city and you think, oh, I'll run a connection from here to here to here to here to here, and something fails in the middle, you end up with nothing connected. It all breaks, it all falls down. And then you have your whole city going into chaos. The whole country can go into chaos. Not just a city, but the whole country can actually go into chaos. We're going to talk about fiber and bringing suboceanic fiber into your cities and things like that, but what I want to talk about is redundancy. And you have to have redundancy in connectivity. That means if something fails, nothing will fail. That's the kind of redundancy I'm talking about. If somebody literally cuts a fiber cable somewhere, you should have enough redundancy in place in the city's infrastructure so that there's a backup artery that will automatically fail over. Smart engineers like my techs that work for me and myself, we can set those kind of things up. It's called fault tolerance. And the better that you set up your fault tolerance, the better you'll sleep at night knowing you're not going to wake up to a city in a financial chaos because banking transactions can no longer occur. Could you imagine all the credit card transactions that are going through all the credit card processing companies? If there's a major failure in your city, you're cutting off the income for all of those businesses for those periods of time. In fact, your emergency services are down. So now if there's somebody dying in a building somewhere, you don't know because your emergency operations phones are down and things like that. Now, I'm sure you guys have redundancy in ways there for the, disaster centers and the fire department and things like that, don't you? Hope you do. So disasters happen in the physical world. Even the financial world is the physical world because credit card transactions are a physical process. You swipe your card, it doesn't work because there's no connectivity. You can't buy your groceries. If that goes on too long, people start starving. Yeah, they can go back and start using their pesos to buy groceries and things like that. But what if their pesos are in the bank and the ATMs don't work because the infrastructure has failed? Now you're in a whole nother world. I mean, now people are making temporary plans to thwart these problems, and they usually don't work out so well. It's a big mess to clean up. Let's just not get into that mess. Let's make redundancy in your smart city. Disasters in the information world, as I said, can occur in physical or in just data. The security, you should have redundancy in the network. You should have security monitoring that network. As I said, have a security and network operations center, because you don't want all of a sudden everybody's social security information and their tax information and things like that getting stolen by a hacker and then released into the world, because that alone can cause chaos. I mean, imagine if some hacker steals information and then uses it to charge $500 to everybody's credit card who's on the list. That's not something you want to face. Target here in the United States had a big problem with that. Several other companies had a problem with that as well. Yahoo just had a huge data leak. I mean, it's a disaster. We don't want that to happen. Learn from the mistakes we made. Don't do them here. Think about movies, right? Every monster has a weak spot. That's right. You see that big Godzilla and you want to take it down, what do? You throw bullets at it, they're bouncing off, so you got to figure out where is the weak spot, right? Every monster has one. The networks of the world all have one. The United States has one. As a matter of fact, there's a single building in the United States. One single building. I won't even name the building because I think it'd be irresponsible to do so, but if something happened to that one building, it would cause chaos across the entire United States. And the reason for that is, back in the very early days of the internet, we didn't have these security problems. We didn't know that banking and internet shopping transactions and package tracking for UPS and FedEx and things like that, we didn't know that all that was actually going to happen. We knew we had a network, and people started connecting one thing to the other. They're like, oh, this is really cool. This works. Wow, email. Right on, man. They just looked at it and said, wow, we're a bunch of geeks and we created something grand. It was so awesome and it worked so well. But they failed to think about the future of all the cyber criminals that will come along, the future of all the threats that can take down the entire country. See, they never corrected it. They had a building, all these wires went into it, and very, 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 very many very important companies still connect to that building to this day. And if that building went down, I don't want to think about the kind of problems that could happen, but luckily we realized that, and they're in the process of fixing that issue by distributing the things that were in that building all across other places. But it takes many, many, many years to do that. When you have many, many, many years of infrastructure that went into one place, and that's all live and operational, it can take 20 years to migrate out of that. So it's a really serious matter. Here's another thing. For redundancy, allow competition. Don't block tech companies from selling internet. Don't make it hard for companies to get in the business of selling internet and VoIP services. Stop with all the paperwork. Allow them, encourage them to start up ISPs and data businesses, because the more there are, the more peering there is, the more redundancy there is. If you have a monopoly in your city and there's one incumbent carrier that is the main people and maybe one other one that kind of isn't that great, you really don't have much. For example, just in the city that I live in Eastlake, California, you have a choice. You have Cox, you have AT&T, you could call Cogent, you can call anybody. I'm talking about business connectivity, okay? I'm not really talking about the houses and things, but there's no less than like 100 companies you could call and get connectivity from in the Eastlake area. In Mexico, my guess is that in most areas there's one or two, and maybe some laggards that are around that have barely working networks because they don't have infrastructure. Share easements. Work to establish policies and plans so that ISPs that want to expand can use the telephone poles, can use the conduits in the street to run fiber, to create redundancy. If you let them do that and you don't charge them for it, they will build your infrastructure for you. They will help you make your city smart, and it'll save the city money. Don't charge them. Don't make them go through legal hurdles to get permits and things like that. Open the door and you'll see the benefits of it. The cities will save tremendous amounts of money because you won't have to build all of the infrastructure. All the new businesses that are coming out are going to help build it for you. Allow sub-oceanic fiber to reach your shores. If your city is on the ocean, ask for companies to bring fiber to your shores, into your city, because that fiber will then connect your city and all the other cities surrounding you, and it'll help everybody globally. Not just in Mexico, but in other parts of the world. Because if you have a website that's hosted in Mexico and somebody from the United States wanted to get to it, the more routing there is, the more peering there is, the more sub-oceanic fiber that comes in, the more arteries there are for data packets to follow, the faster those websites will load. And it'll make like e-commerce better and more profitable for those people running online businesses because they can now do international trade a lot easier. Education. Education needs to start in the lower schools, not just in college. Not even in upper school. You have to start in lower schools with technology. Have to start training the children, because if you have a smart city, you're going to quickly find out that you need a lot of smart people to keep that smart city running smoothly. Why not train them young? Create a whole new breed of people who can actually run these smart cities long after we're gone. For the city to operate those fancy things, you got to have fancy-minded kids to do it. So let's get them all trained, right? Together we can improve the quality of life through technology with your smart city initiatives. Hopefully your initiatives will mostly include infrastructure, followed by things that improve the life of the citizens in your city, followed by the things that enable your city to do better business with the other cities and the rest of the country. All of these things together spell success. I wrote a little note here. I should give you my email address. I'd love to hear comments from you. I'd love questions. Any way that I can help, please email me and let me know, because I know a lot and I'm here to lend you a hand. I'll listen, I'll answer your questions, I'll give you any advice that you need, or if you just want to chat, send me an email, nj@mie.mx. That's nj@mie.mx. Let's hope we meet soon in the future. Maybe next time we'll be able to make it there in person. Hopefully that'll happen. I look forward to it. Have a wonderful day. Bye.